In this video, we are going to talk about how to solve systems of equations, and we're going to get into how to solve systems of equations using matrices. So let's just review quickly how you solve systems algebraically. So one way is by graphing. And so systems of equations are just two or more equations that you find a solution to. So if we were going to graph them, we would want to get them into slope-intercept form. So we would need to subtract 2x from both sides, and then divide by -8. So -2 divided by -8 is +1/4. 24 divided by -8 is -3. Then we would graph this. So -3 being the y-intercept, so we would start at -3, and then we'd have a slope of up 1/4. And then we can just move this line backwards as well. Whoops. Okay, so then that's that line. That's all the solutions to the red equation. And then we'll solve the next one. So subtract 3x from both sides, and then divide by 5. So now this one gets us a decimal for the y-intercept. So the y-intercept is at 0.4, so just about a half. So we're going to graph this and see if it looks like we can tell where they cross. So this one starts at a y-intercept of 0.4 and then has a -3/5 slope. So down 1, 2, 3 over 1, 2, 3, 4, 5. And then 1, 2, 3, 1, 2, 3, 4, 5. So that would be the solutions to that line. And so then it looks like these ones cross exactly at this point right here, which is 1, 2, 3, 4, -2. So then that would be the solution to this system. We can just check just to make sure, since we had a decimal there and we want to make sure that it actually crossed there. So you would plug it back into the original equation. So 2 times 4 minus 8 times -2. So this is 8 plus 16, which is 24. So it's definitely a solution to the red. And then 3 times 4 plus 5 times -2. So this is 12 plus -10, which is 2. So it is a solution. So the solution to a system is where they cross when you're graphing. So that's the solution there. We have the same system here, but just a recap on substitution. So we know the solution is going to be 4, -2. We just found it. But for substitution, what you would do is you would solve one of the equations for one of the variables. You can choose which one seems like it's going to be easiest. So if you had a coefficient of 1 in front of one of your variables, I would start there. This one, I'm just going to solve the top equation for x. So I'm going to add 8y to both sides. And then I'm going to divide by 2. And then what you do is substitute this into the other equation where you see x. So we're going to take this and plug it in for x in the other equation. So our other equation is 3 times x plus 5y equals 2. And so now instead of x, we're going to have 4y plus 12. Then you're just going to solve this equation. So you get 12y plus 36 plus 5y equals 2. So 17y plus 36 equals 2. Subtract 36 from both sides. Divide by 17, and you get -2. Okay, which is consistent with what we found. Then you plug this back in. And I would just plug it back into where you already have x solved for, or the other variable, because it's just going to be easiest mathematically. So then just plug it back in there. So you get -8 plus 12, which is 4, again, consistent with what we found. So that's just a quick recap on substitution. Then a quick recap on elimination. So you want to get the coefficients of x or y to be opposites. So when you stack them on top of each other, we want these to be opposite numbers. So if we have one equation that we can multiply to get it to be the opposite of the other, we would want to. In our case, we don't. Okay, I can't multiply 2 by a whole number to get it to be -3. I can't multiply 5 by a whole number to get it to be 8. So I'm going to multiply this top equation by 3 and this bottom equation by -2. So then that's going to get me 6x on top minus 24y equals 72. Then on this second equation, I'm going to get -6x, so I have opposites, -10y, and then -4. So once you have opposites, you're going to add those equations together. So this is going to eliminate one of your variables because 6 plus -6 is 0. -24y plus -10y is -34y. And then equals 72 plus -4 is 68. We'll divide by -34. And we'll come up with y equals -2, which we know is correct from the last two. Then you take this and plug it into either of these two equations up here to get your x. So I'm just going to plug it into the top one. So we just have 2x minus 8 times -2 equals 24. 2x plus 16 equals 24. Subtract 16 from both sides. So you get 2x equals 8. Divide by 2 to get x equals 4 to come up with a solution again of 4, -2. So that's the algebra way to solve it. So we're going to get into matrices today that are going to show you a much quicker way to do some complicated systems. So one thing to just remember is if you're solving a system, if your variables cancel out, okay, so if when you canceled out the x's, the y's also canceled out. If you get down to a false solution, so you get down to a false statement that says 0 equals 2 or 3 equals -1, something that's not true, then this means no solution. It means if you were to graph these two lines, they'd be parallel lines, so they wouldn't ever cross. So you'd have no solution. A true statement would mean, so if you get 0 equals 0, 7 equals 7, something that's true, that would mean that when you graphed these lines, they were the exact same line. So they graphed on top of each other. So they have all the same solutions. So there are infinite solutions to this. So that's going to show up a little bit in some of these matrices problems. So one thing that we have to know in order to be able to solve using matrices is what an augmented matrix is and how to write it. So the way that you write an augmented matrix is you're just going to use the coefficients or the front numbers of each of your variables. Now you have to have, when you write an augmented matrix, you have to have enough columns for all of your variables. So you're going to have an x column, a y column, a z column, and you're going to have a constant column. So this is how your matrix or how your equations need to be set up, is with your variables on top of each other equal to the constant number. So in this first column is going to be the coefficient of the x. So we've got 4 for the first equation. Then we need the y. There isn't a y in this top equation, so that's a coefficient of 0. Then the z is 3, and the constant number is 12 for that first row. Second row, the constant in front of the x is 2, the y is -4, the z is 12, and the constant number is a 6. Third row is 3 for the x, -6 for y, 18 for z, and 9 for the constant. So again, make sure that you have it as kind of written like this: ax plus by plus cz equals d. It has to have all the variables on the left side and then the constant number on the right side. So if you had a variable over here, let's say we had something like 3y over here, we would need to subtract that over to the other side before we write the augmented matrix. So for this next one, so we're going to have an x column, so 3 for the x, a y column in this first equation is the -9, then we have 12z, and our constant is 6. Second row is 2 for the x, negative 6 for the y, 8 for the z, 1 for the constant. Final row or third row is 1 for the x, 2 for the y, negative 4 for z, and 7 for the constant. So augmented matrix means that it's got one more column than it does rows. So we need the same number of rows as there are equations, and then variables with the constant. So then we're going to end up using that augmented matrix to do what's called row reduced echelon form. And a calculator will do this for you. So there are algebra ways to do it that you may learn in college math if you go there. But we're just going to have our calculator do it. So row reduced echelon form is going to have an identity matrix, which is simply just ones along this column. So if it's a 2 by 2, it's got ones along this diagonal, zeros everywhere else. A 3 by 3 is going to have 3 ones along this diagonal and zeros everywhere else. So you're going to see that identity matrix and then the answers to your system. Okay, so we see this identity matrix here. So if it's a 2 by 3, we see the identity here, 1, 1 along this diagonal. And then we see the answers. So I'm just going to put a little dotted line in here to show you kind of a break here. So you've got the identity matrix and the answers. If it's a 3 by 4, you see the 3 by 3 identity matrix, and then you're going to see the answers. So if we think back to how we said that each column represented a variable, so if we said this was an x, this was a y, and this was the number, if I wrote the equation from here, this top one would say 1x plus 0y, so no y, equals 5. That would be what that top row says. This bottom row then would say 0x plus 1y equals negative 1. So you can see where you get the solutions there. X equals 5 and y equals negative 1. So in this one, if you had 3 variables, x, y, and z, x, y, and z, and then this is the number, okay, then this top line would say 1x plus 0y plus 0z equals negative 3. This middle one would say 0x plus 1y equals 0. And this bottom one would say 0x plus 0y plus 1z equals 8. So you get x equals negative 3, y equals 0, z equals 8. So if we can get it down to this row reduced echelon form, then we have our answers. So let's take a look. Okay, so we've got this system. We've got all the variables over on the left. Okay, so make sure you always have that. You've got your constants on the right. So we see all of our x's, all of our y's, and all of our z's. So when we go to write our our augmented matrix here, okay, so we've got 1, negative 1, 1 for that top row, 2, no y, and then a negative 3z. Then we have negative 1, 2 for those coefficients. So get that written into your augmented matrix along with the coefficients here. Or sorry, along with the constants. So then what you're going to do is you're going to go to Desmos.com. Okay, so you're going to go to Desmos.com. And you're going to click, instead of on the graphing calculator, you're going to click on Math Tools, and you're going to go to Matrix Calculator, and it's going to pop this up. So then you're going to type in that matrix. So you're going to say New Matrix. You want it to have 3 rows and 4 columns. And then you're going to type all of these numbers in. Okay, so now you have that matrix typed in. So then what you're going to do is you're going to click this rref, and then you want the row reduced echelon form of matrix A. So then you'll click A, and you'll see that it does it for you over here. So this is the row reduced echelon form. So then our row reduced echelon form will give us our solutions. So again, remember, here's the identity matrix over here. So this is saying x equals 1, y equals 2, and then z equals 1. So that's how simple that is to solve a system. So what you have to make sure you can do is go from this to an augmented matrix. You have to make sure that you can rewrite as an augmented matrix, get that typed in, row reduced echelon form. Okay, then what's it going to look like when we do no solution versus many solutions? Okay, so when you do this, okay, so again, get this typed into an augmented matrix, okay, and now in this one, you see it's x, y, z again, okay? So then go ahead and get that typed in. It's going to be a three row by 4 column. Okay, so make sure you get that typed in. Then you'll do rref of that matrix on Desmos again. So now what you're going to see happen if there's no solution is this bottom row here. Whoops. So this bottom row is going, let's get rid of this. So the bottom row is going to not have a variable in it. Okay, so this bottom row didn't have a variable in it because remember, here's where the identity matrix is. So this bottom row here says 0 because it's 0x plus 0y plus 0z equals 1. So this is all 0 equals 1. So you always want to look at the bottom row first to make sure whether there's a solution or not. So this bottom row says that 0 equals 1. That's a false statement. 0 does not equal 1. So this right here means no solution when the bottom row looks like that. Another thing that can happen, so if we do this second system here, okay, get it typed in with the augmented matrix, which I've already done, and then the row reduced echelon form. So now when you look at this bottom row, okay, this one down here says 0x plus 0y plus 0z equals 0. So this all is 0. So this one says 0 equals 0, which is a true statement. So if you see something like this, where it's all zeros at the bottom, then this one is many solutions. Okay, it means it just means that all those variables canceled out somewhere, so then you've got kind of many solutions to that system. Now, one thing I will say is some people do get confused and mix up. Let me do one more slide here and show you. A lot of people will accidentally screw up if they get something like this, where there's actually a 1 here. Whoops. I was trying to screenshot that and make it so it looked like a 1. But if you have something here where this one is actually a 1, some people will think that this is one of those situations, but it's not, because remember, this represents the variable. So if you get to this is 0x plus 0y plus 1z equals 0. So this and this would have a 0 here, and this would have a 0 here. But so if you get to this, then that's saying z equals 0. So then you're getting y equals 6. So you got z equals 0, you get y equals 6, and you get x equals 9. So this one is a solution. So it's only if this bottom row is all zeros, okay, that's many solutions. Or if you have 3 zeros followed by any number here, it could be a 1, it could be a 7, okay, whatever it is, this one is no solutions at the bottom. Okay, and then if it's, 0, 0, 1, 0, that just means z equals 0.